Hello again, it's me. We're going to now talk about flips or reflections. Same thing, okay? We use them interchangeably. Um, we flipped over either the x-axis or the y-axis, or think of it as a reflection in a mirror, okay? So the way that we get reflections or flipping the graph is when the function is made negative. Okay, this is different than subtracting something. It's when we stick a negative in something. Okay, so once again, let's go through these examples and identify the parent functions. Here we have y equals negative x squared. That's just based on y equals x squared. And hopefully by now we're learning what some of these graphs look like. Let's just graph that parent function right off the bat. Next, we have y equals negative absolute value of x. Our parent function is the absolute value function, which makes a v. Absolute value makes a v. V for value. Okay, next one, y equals square root of negative x. That's our square root function. Here we start at 0, 0. And we don't go into the negatives, remember, because the negative, we can't take the square root of a negative number. If we do, it becomes imaginary. From here, we go up and to the right. And once again, I'm just going to have you cross that last example off. We're just going to do the first three. Okay, so what happens when we stick a negative in front of our parabola? So I have negative x squared. Here we go. Here's our parent function and negative x squared. Upside down parabola. Upside down parabola. That's a little off there. The center should be at 0, 0. So the transformation, we call this a vertical flip or a reflection over the x-axis. I'm just going to say reflection over x. Right? Here's our x-axis. We take it and flip it upside down over that x-axis. That's a vertical flip. Okay, next one. Y equals negative absolute value x. Type this in. Okay, there's our original. And once again, what do we see? We see actually the same thing as what we saw with our x squared function. This is another vertical flip, aka a reflection over the x-axis. A reflection over the x-axis. Okay. Now we have our last one, which is the square root of negative x. So go back to our y equals. I'm going to type in these equations. Square root of x, square root of negative x. And this one's going to be a little different because the negative is where? The negative is in with the x. It's in the square root with the x, as opposed to just being out front. And as we've seen through all of these transformations, depending on where the thing is located in the equation, it's going to change the function differently. So I'm going to click graph. There's my original, and there's the negative version. This time, we have a horizontal flip. A horizontal flip. A horizontal flip means that we reflect over the y-axis. So we go from going to the right over to the left. Now you might be thinking, wait a second, how can I suddenly have negative x values? I thought I couldn't take the square root of a negative number. That is still true. But what happens? Because of the fact that this is negative x, when I put in negative 4, let's say, what's the negative of a negative number? It makes it positive. Okay? So in this function, we can only put in negative numbers because the negative of a negative is a positive. Okay. So to have a vertical flip, the negative has to be at the front. Like in negative x squared or negative absolute value of x. And when we have a vertical flip, which axis do we flip over? We flip over the x axis. A horizontal flip is in with the x. It's in with the x. And when we do a horizontal flip from right to left or left to right, we are going to flip over the y-axis. Okay, you can cross this one off for me. We're not going to do that one. But the key point here is that if we flip, that means we have a negative somewhere in there. Okay? Let's go through these pairing equations again. Y equals negative x. Well, that's just y equals x. Y equals negative x squared. I'm sorry, square root of x. And y equals x squared. So this right here, that's a negative. Where is it? At the front. That is a vertical flip. Same thing as before, I would like you to pause the video, try these two on your own, decide if it's going to be a vertical flip or a horizontal flip. Then when everybody's done, come back and we'll go through it together. So go ahead and pause the video for me. Okay, so here we have a negative. Where is it? It's at the front. This is a vertical flip. Here, the negative is in the parentheses with the x, which means it is a horizontal flip. And funnily enough, if you do a horizontal flip of a parabola, it's going to look exactly the same. I mean, go back up here. Imagine flipping this over the y-axis. It's going to look exactly the same. All right, please flip to page 20 for me. This is what you're going to be working on for the rest of the time today. And this is what I'm going to be checking on Monday for homework points. So, 2.5 homework. You are given a bunch of equations here. And what you are going to do is identify the parent function and the transformation that has occurred. So, for example, let's say I'm looking at number 4. We have f of x equals x plus 4 squared. Well, my parent function is y equals x squared. And my transformation is plus 4. Okay, well, adding and subtracting means that we are shifting. The plus is in with the x, which means it's going to be left or right, and plus actually means we go left. So I would write left 4. So that's kind of how each one goes. Now, I'm going to give you a hint, okay? 1 through 6 are all some sort of shift. Okay, so if you have to go back and look at page 17 to help you out, go do that. 1 through 6 are some sort of shift. 7 through 9 is going to be a stretch or a compression. So look at page 18 if you need some help. And our, so is number 10. Numbers 11 and 12 are going to be a flip of some kind because of the negative. So look at page 19 if you need help there. Okay, so page 20 is your homework, and I would love for you to work on it now while you're in class. You can have it done, and then you don't have to worry about it this weekend, and you can do all the fun homecoming things. Hope you have a great day and a great weekend.